So here is an open source model, state-of-the-art model, Kimi K2. And here's the download option. So you can see there's all kinds of options. There's this option that takes 2 terabytes, then there's these and these, they take 500 gigabytes, then there's even this that only takes 280 gigabytes. So what is this? What are these things right here? Now these are quantizations that AI models use to basically compress the weights to smaller values so it can fit to less space. So let's explain that. So when a model is trained, the weights it has are stored in usually 16 bits. So that is 16 bits of storage for each weight. So that means it will take 16 bits to store each weight, each of the 1 trillion weights. But as we saw there, it takes a lot of space, like 2 terabytes to do that, to store that, which is not very good when you want to run the model, because that would mean you would have to fit 2 terabytes of the weights into RAM or VRAM, and that is a lot of space and we don't have that much RAM. So what do we do then, right? We don't, like, the model works with 16 bits, but what we can do with quantitization is that we compress each weight of the 1 trillion weights in this example to be, for example, 8 bits. So that will reduce the model size by a factor of 2, but it actually doesn't reduce the performance of the model basically at all. So the model runs identically while taking 2 times less space and also running 2 times faster, because each weight is now taking only 8 bits compared to 16 bits. But the quantization can go way further than that. So we can compress that even further to like 4 bits. And that is, 4 bits seems to be like the golden standard. So for example, in this case, Google Gemma 3 1 billion parameter model, they didn't even release the 16-bit weights or the 8-bit weights. The only thing they released for the download options is the 4-bit quantized weights. So to sum this video up, these are some common quantizations that local LLMs use right here. Now there's a lot of things like this right here, the Q4, KM, and then there's this, the K, and all this stuff. But this is essentially just technology that uses stuff to make it better. But let's not focus on that. What really matters here for the understanding is that like this one right here means that it is 8 bits per each weight, and this one right here means that it is 4 bits per weight, and this is 2 bits per weight, and this is just 1 bit per weight. And yeah, sure, you have these and these and these, which are different technologies to manage them and do stuff with them, but exactly to have a good understanding, that is basically the core of it. So that so quantization is compressing the weights to be less bits. That way it takes less space, and that way it runs faster, and there is of course performance decrease when you compress. There's always some decrease, but the decrease isn't that much. So for example, the 4-bit weights, if you compare 4-bit weights to 16-bit weights, that is a huge decrease in size, but the performance decrease isn't that huge. So it is completely worth it to do that.